Why are ETs still officially missing? August 26, 2019. The complicated, confusing and exciting quest for alien life mission. NASA is preparing to launch a search for alien planets in movies. The first contact with aliens unfolds with great drama. Often aliens arrive with laser weapons. In more benevolent scenarios, they appear in the form of hooded Vulcans, sympathetic with glowing fingers or black box artifacts buried in the moon. Regardless, the main message is clear: we are not alone in the universe. In fact, the discovery of extraterrestrial life will come with much ambiguity and skepticism. How can we be so sure of that? Because it already happened twice. In 1976, the twin Viking 1 and Viking 2 probes landed on Mars and began the most ambitious effort ever made to seek life in another world. The robots picked up solo and performed 4 experiments. In one of them, a sample was incubated in nutrient broth. It immediately emitted a belch of carbon-containing gas, probably carbon dioxide, and, for an impressive moment, it seemed that Viking had found an alien biosignature, chemical proof of biology in action. Then came the dark realization that Martian surface chemicals could have the same effect without the aid of microbes. The other Viking experiments came without result. NASA's official verdict: there is no evidence of life at any landing site. Gilbert Levin, the researcher who designed the burp test technically called the Abel release experiment, never accepted this conclusion. Paul Davies, director of the Center for Fundamental Concepts in Science at Arizona State University, where Levin was an adjunct professor before retiring, said, "Gil is absolutely convinced that he discovered life on Mars. My feeling is that Viking is an unfinished business." Everyone rushed to say, "Oh, well, that could be right. At the very least, you would think the experiment should repeat itself." Many other researchers now agree, especially in light of the recent discovery that Mars soil contains chlorine compounds that could have obscured any organic material. Almost 2 decades later, Mars starred in another drama of alien life. In August 1996, NASA convened an urgent press conference in Washington, D.C., where a team of scientists presented evidence of fossil and biochemical microbes in an Antarctic meteorite originally from the Red Planet. President Clinton stated that the discovery speaks of the possibility of life. Once again, accelerated excitement quickly gave way to widespread questions and criticism, even ridicule. And once again, the proponents did not back down. Astrobiologist David McKay of NASA's Johnson Space Center went to his grave last year convinced that the meteorite contained traces of Martian bacteria. Hunting in new places punished by these 2 notable occurrences, life-conscious scientists turned away from the Viking approach. Davies says, NASA adorns its missions to Mars with the word life in all of them, but it is not looking for life. She is looking to see if conditions may have been helpful for life. The $2.5 billion Curiosity spacecraft has shown that hot streams have already flowed on the Red Planet, for example, but are not equipped to find living or dead microbes. Improving Viking results will require returning samples to Earth, where researchers can analyze them in sharper detail. This could happen sometime in the next decade. NASA is drafting plans for the Mars 2020 spacecraft, an updated version of Curiosity that would be released in 2020 and collect samples for eventual return. Russia and the European Space Agency are collaborating to bring back portions of Mars soil sometime in the 2020s. And China's official Xinhua news agency reports that the country also wants to launch a similar mission by 2030. Meanwhile, the number of potentially habitable locations in the solar system has grown. Now astrobiologists are talking enthusiastically about at least 2 important destinations besides Mars: Jupiter's moon-sized Europa satellite and the much smaller Enceladus, which orbits Saturn. Europe has a global ocean locked under an icing. Far below, the internal heat of this moon can create hospitable conditions, similar to the hydrothermal vents at the bottom of the mid-Atlantic ridge in the rising East Pacific on Earth. Last December, the Hubble telescope found evidence of water vapor coming off the surface of Europe, suggesting that the ice surface is thin and dynamic. This discovery electrified the team working on a proposed Europa Clipper mission designed to take a closer look, although, like Curiosity, the spacecraft focused on studying the local environment rather than finding microbiological ET. In a way, Enceladus presents an easier case. This 500 km wide ice ball shoots large ice crystal geysers, which apparently originate from underground lakes near the south pole of the satellite. As geysers are ejecting material from the lake into space, a probe could simply pass through the columns, collect samples and bring them back home for study in terrestrial laboratories. Peter Too, a former NASA engineer who has devised a concept for such a mission, calls the mission the most accessible fruit of sample return-style alien biology studies. At this time, however, there is no funding for the project. The invasion of home life. Let's be optimistic for a moment and suppose that over the next decade, Mars, Europe and Enceladus will be fully tested for life. Alright, let's be rampant, dizzying dreamers and suppose all three experiments come back with positive readings. Even so, the results can be frustratingly contested. If we find only fossil remains, the burden of proof is almost overwhelming, as McKay and his colleagues learned the hard way. Complex organic compounds and things that closely resemble bacterial forms readily form without the hand of biology. Even if we recover a hiding place of living alien microbes, this will not necessarily solve the problem. Terrestrial germs can easily infiltrate a laboratory sample and contaminate it. Worse, asteroid impacts could have produced a more fundamental type of contamination, throwing bacteria-infested rocks from the planet to the planet billions of years ago. As a result, the first contact version in the real world may not answer the deeper question, is the Earth an anomaly or part of a huge community of living worlds? Davies says, we are still completely in the dark about what turned non-life into life, and if we don't know what the process is, we can't estimate the odds. Fortunately, there is a way to investigate this issue here and now, without the expense and excruciating schedule of a space mission. Davis explains, if it is the case that life emerges readily in Earth-like conditions, then it certainly should have started many times right here on Earth. Maybe some local aliens live among us, and we don't recognize them yet. Finding the flowering of a second Genesis would be a revelation. Any process that can happen twice can probably happen a million times, or a billion, in locations throughout the cosmos. To find life as we don't know it, Davies suggests looking for microbes that thrive in extreme temperatures or depths. A particularly telling result would be to find organisms that use mirrored versions of familiar biomolecules, making their metabolism incompatible with that of any known living thing. This kind of research is the perfect project for an era of tight budgets but broader visions. He said, in the 1960s, when I was a student interested in life beyond Earth, I might also be interested in looking for fairies. Now most scientists have the preconception that life is everywhere. Can we test this? It does not require much effort. It just requires people to be open-minded.